Math 3 Lesson Summary Video. Lionfish Hunters. This lesson is a solidify understanding task, which takes concepts developed previously and helps you formalize those ideas. The purpose of this lesson is to model compound interest with exponentials and find the relationship between annual percentage rate and effective annual rate. Elijah's parents and older siblings formed a team and named themselves the Lionfish Hunters. They participated in the annual Upper Keys Lionfish Derby and won the first prize of $1,000 in the most lionfish caught category. They have decided to put the winnings into savings for Elijah's college. Elijah just started kindergarten, therefore the money will be earning interest for 13 years before it is withdrawn to pay for college. Which type of savings account should they deposit the money in? One with an annual interest rate of 5% compounded annually, an annual interest rate of 5% compounded semi-annually, and an annual interest rate of 5% compounded quarterly. So you have a table that helps us kind of walk through how we might approach and think about this situation. So first, if we want to think about how many times is interest calculated, when we say interest is compounded, that is the term that we use to talk about how often is the interest actually calculated and added to your account. So if it's compounded annually, that's just once a year. So if he's going to keep it in the bank account for 13 years, he's going to get interest calculated 13 times. Semi-annually means twice a year. If you've ever gone to a semi-annual sale, it's a twice-a-year sale. And so if he's keeping it in there for 13 years, but his interest gets compounded twice each year, he's actually going to have his interest compounded 26 times. And then quarterly, that's going to be 4 times per year. And so again, if it's 13 years, and then each year he gets it compounded or he gets his interest calculated 4 times, then that's going to be 52 total times that he actually gets his interest compounded. What is the percent for each interest calculation? Another interesting thing is that if they give you the annual percentage rate or the annual interest rate, in case you didn't know, if you've ever heard on a commercial API, they love to throw that around on car commercials all the time. That stands for annual percentage rate. An annual percentage rate is how much interest over the whole year. So if he's only getting his interest compounded once a year, then each time you do the interest, you're actually going to do the full 5%. But if it's 5% for the whole year, but you compound it twice per year, that means the first time you're going to do 2.5%, and the second time you're going to do 2.5%. So for the whole year, that's a total of 5%, but each time you do that computation, you're doing 2.5%. Compounded quarterly, again, it's 4 times a year. So over the whole course of the year, I need to do 5% interest, but each individual time, I'm only going to do a fourth of that. So a fourth of 5 is 1.25%. So don't forget, an annual percentage rate is how much interest over the whole year do I end up dealing with. But if it's compounded more than once a year, I'm not doing 5% each time it's compounded. I'm doing 5% for the whole year. Now, what formula would we then use to figure out how much interest he earned? So we're starting with $1,000. We're adding, so it's growth, so it'll be 1.05, and then to the 13th power, because that's how many times we're calculating that interest. For the second one, we still started with $1,000, but it's going to be 1.025, and instead of me doing that multiplication 13 times, I'm actually doing the multiplication 26 times because it's twice per year. And then, again, just started with 1,000, but it's 0.0125. And instead of just calculating and doing my multiplication 13 times, I'm actually going to have to do it 52 times because we do it 4 times per year. So that would mean if it was compounded annually, after 13 years, he would have 1885, 65. And then if it's semi-annually, he'd actually make it up to $1,900. And then if it was quarterly, 1907, 84. What is the compound interest formula when P amount of money is deposited at R% annual interest rate compounded N times a year for T years? So if we think about what we did for our table, things that we had to consider, things that stayed the same, things that changed. If we want to know what our compound interest is, so this is going to be what's our total interest and everything over T years. We still have an initial amount of money. That P doesn't change. You have to start with a certain amount of money. We are earning interest, so it is still going to be 1 plus. So there are things that are very similar to just our standard exponential model. We have an initial amount. It's growth, so we are adding to 1. But things that we had to keep in mind is if it was compounded more than just once a year, we have to take whatever that percentage rate is, and we have to divide it by the number of times we compounded it a year. If we compounded it twice a year, we divided it by 2, because that we have to figure out over the whole year, how did we get that rate? So what was each individual time? The other thing that changed was that this number up here got bigger based on how many times a year was it actually compounded. So if it was twice a year, we had 2T because it was 26. When it was quarterly, it was 4 times whatever T is. So the number of times compounded needs to be taken into account as well, because we're not just multiplying it once a year. We're doing it twice a year or 3 times per year. And so that's where this compound interest formula comes from. So don't forget, P is the amount of money that you put into it. It's your initial rate. R is your annual percentage rate. N is the number of times of year it's compounded. And then T is still in years. All 3 accounts start with the same amount of money and use the same interest rate. Why are the amounts after 13 years different? Because we kept the money in the account for the same amount of time. We used the exact same interest rate. The only thing that changed was how often it was compounded. And the reason for that is going to be that when you compound, you actually put that interest into the account. And so then the next time you're computing what you're going to add to the account, there's actually more money in there. So each time you're calculating interest on more money. So if you compound more frequently, you're going to make more interest on that money that's already put in there. So it's because you're earning interest on interest. That money that you've added to the account is now part of the calculation for figuring how much gets added. And at the beginning, it may not be very much different. Pennies, parts of a penny, depending on how much you put in. But the more money is in the account, the bigger difference that starts to make. And so that's why you usually see these grow very big at the end, because the amount that's getting added is changing greatly. Are the amounts growing at the same rate? If not, what is the growth rate at each account? The effective annual rate. So what do we mean by effective annual rate and the annual percentage rate? So the API, again, is the annual percentage rate. How much interest are you sticking in there over the course of the whole year? So 5% interest is what I'm going to compute over the course of the whole year. I either do it once. We said it was 2.5% if we did it twice a year, because I do 2.5 and then another 2.5. And then 1.25 when it was quarterly, because if I did 1.25, then we did 1.25 again, then did 1.25 again, and 1.25 again, that would be 5% over the course of the whole year. So it's just taking your percentage that you calculate each time, adding that up to give you how much percentages did you take over the course of the whole year. An effective annual rate is if we were thinking about it just as our good old-fashioned exponential, We have an initial amount, we have our year, and then we have 1 plus the percentage rate. How much is its actual annual growth rate? So that's going to be different than just taking and adding up our percentages over the course of the year. We actually want to know what was the percentage that was calculated, how much did it grow from one year to the next, taking into account all that compounded interest and the interest on top of itself. So if we think about API, if it was just one time per year that we were compounding it, that is the effective annual rate, because each year I calculate it once and then that's how much I add in. So that is 5%. But if I'm going to have 1.025, here we had 1.05, and then it's just going to the 1 year power, so we just had that 5%. But if I have 1.025 and I'm doing it twice that year, so it's 2 times. Now when I do 1.025 to the second power, I get 1.0506. And so instead of it just being 5%, it's actually 5.06%. Now that doesn't seem like a lot. You're like, that's not even a whole 0.1%. But again, depending on the initial amount of money in the account, that 0.06% can start to turn into some significant amount of money. The same idea down here, I'm actually doing 1.0125, but instead of it just being once for that year that I'm compounding it, it's actually 4 times per year. And 1.0125 to the 4th power is 1.0509. Not a big difference, but a difference nonetheless. So that means that the actual effective annual rate, how much it actually ended up growing over the course of the year, is 5.09.